Swayam Prabha. Digital India. Educated India.
Welcome to today's lecture. This is on hydraulic circuits in industrial application. Now, a hydraulic, more generally any circuit, is an arrangement of individual components to discharge a desired output. Now, here what we find an example, a scheme of hydraulic circuit. Like electrical circuit, we need to draw also hydraulic circuit, and mainly in hydrostatic transmission system, or so to say any hydraulic systems, we need to procure the components. These are not individual components are designed, rather circuits are designed, and we put together those components connected by the hose or pipes, and then it performs for a particular requirements. In this schematic view, what we find that there is a pump. Pump is driven by a motor, and then essentially there is a pressure control valves. Pressure control valves in that groups, that may be pressure reducing valve or anything, but here pressure control valves mean actually this is a safety valve, that is pressure relief valve is used. Then we need to have direction control valve, what we have learned in the first lectures. Then flow control valve and linear actuator, or maybe there and rotary actuator. Now, in many cases you will find that this direction control valve and flow control valve may be combined together, or a separate flow control valve is used, and some cases we do not need the flow control valve at all, because even if there is a fixed displacement pump, but the velocity of these actuators need not control, only it should actuate and it should retract also. Now, with this scheme, then what will be the actual circuit? In actual circuit, again this is, we use the symbol, this is pump and coupled to the motor, and then this is pressure control valve, which is nothing but a pressure relief valve. This means that if the system pressure exceeds due to excess load, in that case the flow will bypass through the pressure relief valve, and in that way it will shape the circuit. Now, here we find a direction control valve. This direction control valve, looking into this symbol, if you know these symbols, we have already learned this is 4 by 2, that this means that 4 ports are there and 2 position. This is one position, this is another position, and this spring means in one side spring means it will assume only one position when we do not actuate this lever. Now, here as shown that in normal condition it is like this, that means a cross connection is there. Cross connection means the flow is going in this directions, then this is being retracted. Okay. In that case, possibly it will rotate in one direction. It is not possible to indicate by this symbol only. And when we actuate this, the spring is compressed and we get this path. In that way, oil is going through this and then this is actuating, and oil from this side is being returned to the tank. Now, what we find, when this connection is there, oil is coming through this to the tank. In that case, if you look into this, there is a flow control valve. In that flow control valve, what we find, there is a check valve. This means that oil will return by blowing this check valve, and it will return to the tank almost without any resistance here. Whereas, if we connect this one, in that case oil is going through this, and we can, this arrow means we can vary this, that means we can control the flow. So, there will be a controlled flow for actuation. This means that depending on load we may control the speed also. So, in that case this is a fixed displacement pump, but still this velocity can be controlled. And if we actuate this one, if we use this side, then say this connection is not the connection here, this is just bypassing, I mean this is one line, this is another line. So, oil may come this side, again there is a flow control valve. This means that we can control this speed of this motor also. Now, here this motor in one directional, and oil is being returned directly to the tank. There is a, it is possible that we can move this and as well as this, but depending on load we do not know which one will move, because oil will always flow to the least resistive path. Okay. So, this is just to show that how this circuit can be designed. Now, so this is a simple circuit, and we can design the circuit like this. And if we have a little knowledge about this symbols, in that case what we find that this is this can be regulated as this arrow is there, and this is also that depending on the pressure this will operate. So, this means that suppose this here we working with 10 megapascal, this is also maybe the system pressure is 10 megapascal due to the load. In that case we will probably set 10.2 megapascal. Then if pressure exceeds above 10.2, that means above 10, almost above 10, then this will blow and oil will go back to the tank. To make such a system energy and cost efficient, but reliable and safe, selection of proper components is more crucial. Nowadays, with the crisis of energy everywhere, so almost in all design it is always thought of how the energy can be saved. For your information, if we want to control, say flow control, pressure control, particularly where we use the servo control, always we should keep in mind that there will be pressure drop across the valve orifice, and in that way there will be loss that we cannot avoid. However, by arranging the system that where we can according to load, if we can control this part, then probably we can save the energy. Now, it definitely needs designer skill. There are systematic methods, that means if we have thorough theoretical knowledge and some little bit experience, probably we able to make the energy saving circuit, but always it is there, you need an experience to make a good circuit. It is known that fluid power overlaps with practically every branches of engineering, controlling or powering some part of it. This means that fluid power is used almost, I mean every, say if you go to the production engineering, if you go to the missile, even if the spacecraft, there you will find the fluid power is being used. It is together that supply of power, I mean power conversion. Usually there will be a motor to drive, in this case drive a pump, but that power give the translatory motion as well as rotary motion with torque conversion. Okay. And as well this can be controlled also. Say for example, we are controlling the speed through a flow control valve, and fortunately in this case this control signals also passes through the oil hydraulics, and oil hydraulics, in that way the oil medium is very good for transmitting control signals. Now, with all these versatility and flexibility, the circuit designer has a big responsibility towards the user of circuit designed. One must therefore be aware that the final product, that is the designed circuit, essentially is designed to discharge full reliability under adverse or unexpected conditions. Secondly, functional and meets the required performance specifications for its purpose of control and power transfer. Thirdly, efficient and economical without wasting power. And finally, to be energy saving, simple in design and hardware applications. This is one is that wasting of power, we say this means that suppose the oil is flowing through the pressure relief valve. In some cases we will find that when the system is idle, then oil is flowing through this pressure relief valve. That is definitely wastage of power. That can be made, we can make such system that we can save the energy either using this oil for some other purpose, or we can use this valve such that when this system is idle, the oil is flowing through this valve without much resistance. Many industrial hydraulic actuations take place at low force for most of the time in a cycle of operation. Actually, while we are designing, we can go for various systems definitely, but depending on the operation cycle, how much we need to operate the circuit within a time period, depending on that we can design the circuit accordingly. In many cases, if you find that the circuit is almost being used for the full time with load, in that case we perhaps can go for a little expensive components, so that these are used, the circuit is used efficiently. Whereas, in case if we find that it is not being used, say it is being used for 5 minutes and then 10 minutes gap, in that case we can use a low cost items, but there is such a system when it is idle, the oil is going through the less resistive path. In such cases, it is desired that required high flow at low pressure should automatically converted to low flow high pressure when the actual working stage in the cycle of operation is reached. Incorporating proper devices, such sequences are possible, that we will learn in this lecture. The following 4 methods are frequently adopted to achieve rapid approach with low force and automatic changeover to slow work stroke with high force. Number 1 is that high low double pump system. This is high flow and low flow. This means that high flow and low flow. Then second one, this means that when we need low pressure, we can have high flow, so that we can use the power fully, and when there is a high pressure, that means high load, then low flow. Now, kicker actuators with pre-fill valve and header tank, this is one arrangement. So, I shall explain what it is. In that way also we can save the energy, and the sequenced regenerative system, and fourthly variable displacement pressure control pump. Among this there are few more components will be there, but still perhaps this one will be the expensive one, but still these four are the common which are adopted to save the energy, but these are just general. There are many other arrangements possible, and combination of these again may give better performance also. Now, first of all, it is better to study that how the total mapping of the power utilization during the operation. So, in many cases you will find the operations are sequenced, and maybe we can identify one operation cycle. If we study one operation cycle, in that operation we know what is the speed, what is the flow, etc., and from there we can design our systems. We can have say discrete manner, these are the flow, this is the pressure, these are the flow, and this is the pressure, and from there averaging that we can select the motor, pump and required components. However, if we think that very high force and flow, maybe the speed is less, in that case we need this much we can select our, this is one operating zone. On the other hand, this very high speed, but low pressure. Okay. Then this is we can have this power curve is like that. From there what we find that in this system, suppose if we use this force, we can go up to this speed. If we use this much force, we can go up to this speed. So, we can now select the devices in such a way that whenever we need high speed, we can reduce the force, or in other words, if there is a less force, then we can move with high speed. And this in some cases it is automatically adjusted, in some cases you can adjust it manually. In that case, control might be very discrete manner. Suppose if we let us consider we are using for hammering or pressing something. If we see that this pressure we need less pressure, immediately we can adjust, then probably that it is being done at high pressure, but using low pressure. So, that adjustment manually we can do like that, and for that study we need similar graphs. This is any two 4 speed coordinates intersecting of the curve represent the actual power requirements. Now, we will study some energy saving circuits. Now, here high low double pump system. This is high low means again high flow and low flow. In that way these are named. Now, what we find that this is we find a bigger circle for the pump symbol, that is for high flow, but it operates in low pressure, and here what we find that this is low flow, but high pressure pump. Now, when there is totally low pressure, it is operating low pressure, that means say this maximum pressure is 10 megapascals, but this pump may be with 5 megapascal. Okay. Sorry, this pump maximum 5 megapascal and this can go up to 10 megapascal. This means that at 5 megapascal, whatever the flow, total flow these two pumps can give, that amount of flow into 5 the megapascal flow in liter per minute megapascals will give you as the power. So, the motor is selected accordingly. Now, when the pressure exceeds above 5 megapascal, then what we will find that this flow is being utilized, this flow is going back to the tank, and for that flow very little amount of power is required. So, full power is being utilized, the 10 megapascal into flow of this. Now, how it is operating? Let us study this one. Now, essentially in this circuit, the one reservoir, the strainer, whatever is there, and then the common input is there, and here is a common shaft driven by this motor. So, when this motor is rotating, both pumps are rotating. It is not that one pump we can off. The impeller inside, whatever impeller or piston actuator or whatever there, that are moving. That means, it is pumping the flow, and pressure is always experienced by the load. It is not that pump is pumping the pressure. Pump only must be able to withstand with that pressure. Do you understand my point? Say, whenever the impeller is moving, whatever impeller or piston, whatever is moving, the flow is there, and at low pressure there will be less leakage. So, flow is full. With high pressure there will be leakage, but usually the volumetric efficiency of such pump, this common case may be 90%. So, 90% of the flow will be always there, and pressure is always experienced by the load. Now, these two pumps are being rotated, then what we find that these are connected here, and there is one non-return valve. And then what we find, this is tandem center 4/3 DC valve. You know, understand what is looking into these symbols. Say there are 4 ports, that is why you have written 4 here, and then this is called P port. P is not for the pump, this is for pressure, this one is pressure port, and this is T port, that is going back to tank. And here one non-return valve we can use or we may not use, and but this is at low pressure, this oil can bypass to the tank. Okay. Then 3 positions, this is usually called neutral positions, and this is one position, this is other position. And then what this symbol means? This symbols means that there is a control by a hydraulic actuation is there, and as well there is also solenoid valve, electrical control is there. And what we find, there is spring. This means that if we actuate this way and then if we relieve the actuation load, it will go back to the neutral position due to the spring, same to this part also. And there is also whatever leakage is there, that drain is there, this is called drain port. Anyway, this valve, why we call it tandem? You will find this valve will have either 4 ports are closed, and extreme is that 4 ports are open at the neutral position, that is like a connection capital H. And in this case 2 are closed, that means load side is closed, but this side is open. So, that is why it is called tandem valve. Okay. Then that means in normal course, if we do not actuate this valve, this flow will go through this and it will go back to the tank. Now, this is called off-loading valve, this is called pressure relief valve, and also it is called off-loading valve. what is there, that a connection is from here to this side. That means, if, and again it can be adjusted here, then if the pressure exceeds, then this will connect this part to tank. And what is there looking into this connection, that this is works on somewhat differential pressure. That means, from this side also pressure is being sensed, and this is called offloading valve. This valve is called offloading valve. Okay. And this is a pressure relief valve. This is when the total system pressure, say 10 megapascal. So, when this pressure will exceed 10 megapascal, then this will, the oil will flow through this valve. Now, we can, even if we omit this valve, and if we are sure the pressure is not exceeding 10 megapascal, then also this circuit will work. So, this is basically for safety valve. Now, how it is being operated? Now, the actuator extends rapidly using both the flows at low pressure until the set pressure is reached due to increase in load. Now, here say suppose this is pressing something. Okay. Then what will happen? Initial pressure is low. So, both flow of both pumps will mix together, and this is giving the pressure to that, and it is moving very fast. Now, pressure is increasing, say suppose it has increased above 5 megapascal. In that case, if we need to move at the same speed, we need more power here. But if we use a motor of more power, then initial stage it will the power will be lost, because we do not need that much pressure, that much power. Now, in that case what will happen, say pressure is exceed that much, then this will open. So, oil of this will, instead of going this way, it will go this way and go back to the tank, whereas flow of this and pressure is high. So, it is keeping this closed, it is not going this way, it is going directly to this side, and this is moving with slow speed. The high flow pump is then offloaded, this is offloaded to tank, and the low flow high pressure pump handles the load using the power of prime mover. It is an unloading, this is earlier we have learned what is unloading valve, unfortunately this is for the other class, or offloading circuit. I shall discuss a little bit about this valve also. So, just looking into symbols, you see this, what are the names of such valves. Then during non-action period, both pump flow are diverted to tank through tandem center valve. This means that we are saving energy in that way when it is not being operated. Now, there is you may think that if we use, suppose it is a closed center, that means 4 ports are closed at neutral position. What will happen? In that case, this flow, say pressure will initially increase up to 5 megapascal, then say suppose this is blocked, and in that case this oil will go back to this tank here at 5 megapascal, this pump will be off, but unless the pressure is increased to 10 megapascal, this will not be blown. Then in that case, this means that this pump will operate with 10 megapascals, and then this pump will operate at low pressure and oil will go back to the tank. But still, if you think of 10 megapascal of this flow, almost the full power of motor will be used. In that case, say power is being wasted. But the question is that still there are closed center valves. Why we should use the closed center valve? Closed center valve is used that where we need the frequent operations and we would like to keep the oil ready for operation always. In that case, we go for closed central valve. However, for such operations usually you will find that this is with tandem center and this is a very good energy saving circuit. Now, this unloading valve and circuits what we have learned earlier, say this is the same, this is very schematic view of that system. This valve is also pressure relief valve. If you look into this valve and this valve, there is not much difference. This is pressure relief valve, whereas this is we are calling unloading valve. In that case, actually the control pressure line is connected in such a way, when pressure exceeds some limit, then only this operates. So, that is why it is called unloading valve. Now, how it looks like? It is something like this. You will find that in normal case the pressure is coming over here, that this is from the pressure side and this oil is also coming over here, and then at when this pressure exceeds, then this opens and then all the oil flow through this. I mean actually it is like that. This is one pressure line, if you remember the other side, this side, and this is also another line, the oil is coming like this, and when this exceeds some pressure, then this opens, all the oil goes back to the tank. So, this is called unloading valve. So, this you can compare with this low pressure high flow pump connection. This side is from the main loading system and this is the control pressure and this is the spool. Normally this remain closed. When this pressure exceeds some limit, then this opens and oil go back to the tank. Okay. The symbol is like this. So, this means that this is the valve, this together usually you will find this non return valve is also incorporated here. So, together is called unloading valve and this symbol is like this. This is the primary port, low pressure pump, this is the secondary port to the tank and this is main system with HP pump. Main system pressure is higher than set pressure, only HP pump flow is used. No flow through this check valve at that conditions. So, this is another view. Main system pressure is lower than set pressure, both HP and LP pump flow are used. In that case, flow will be through the check valve. Oil is coming here and check valve is blown and oil is going to the main system. This is another example of I mean this, if we summarize this, we can write an unloading valve is also another version of sequence valve. Now, sequence valve will come a little later. The sequence valve and the unloading valve, their features are more or less same. Only thing this by the control pressure, this valve is operated in a different manner, then we called sequence valve. It allows the pressure to build up to a value determined by a pressure setting. It is two-way valve generally used to bypass part of the circuit back to tank at very low pressure. The internal draining occurs. Double pump system as shown in figure is an example of unloading valve. Using the same power, two outputs and mixed up at low pressure. At high pressure, only the flow of one pump is used by the system, whereas the flow of other pump is diverted to tank at a nominal pressure. Now, so far what we have discussed, say if it is say unloading circuit, energy saving circuits. So, this might, if it is a short note, you may use the answer a brief description how it is working, and then this few points, that will be a short note type questions. But otherwise describing all such thing, you may expect that this is a full question, how this unloading valve is works and how it can be used for energy saving with low flow and high flow pumps. Then discuss the second point. If you remember, we talked about kicker actuators with pre-fill valve and header tank. Now, let us see this circuit first. In that case, we find this pump, and then as the arrow is not there, then we should call this is a fixed displacement pump. That means, when we run this motor, it will rotate at a fixed RPM, fixed speed, except we can control the motor of course, but the pump displacement is fixed. What does it mean? If you have the idea of swept volume, that is volume displaced in one revolution, that remain constant for this pump. This flow may be varied by varying the speed of the motor, which is not usually done. Then in that case, we have one fixed displacement pump, and then this is the pressure relief valve. It is not only pressure relief valve, as we find that this is the pilot line from this side and pilot line from other side also. Usually with this some symbol, it is, we should say that pressure reducing valve, that we can also control the this reduced pressure. But anyway, this system will work if we use ordinary pressure relief valve here also. Then again, this is tandem 4/3 DC valve, the same valve what we have discussed. After that, what we find that there is two cylinder. This is the load platform. The load will be, let us consider it is uniformly distributed in a sense. Then when this is, we say it is a press, then it is pressure over this platform is uniform. Let us consider for the clarity. Now, we find these two cylinder of smaller area. These are called kicker actuators, whereas this is the main actuator. Okay. Then what we find that there is a header tank, and from this header tank through a non-return valve which is called pre-fill valve, that is connected to the main tank. And then what we find in this non-return valve which is called pre-fill valve, this is also pilot operated. That means, by controlling this, we can allow the flow from this side to this side also. When this symbol is there with these dotted lines, that means this can be operated, I mean flow can be allowed from this side by actuating through this signal. This is the control line. Now, this is called pressure sequence valve. If we look into the unloading valve and pressure sequence valve, symbols are more or less same. Only you can say that by slight minor operational change, operational feature, the name is different. So, how it operates? Rapid approach with minimal force output is achieved by diverting the flow from the pump to the two kicker actuators only. So, when there is a little force, then what is happening? So, we have connected this one, connected this means this path is connected, that means it is actuated this side, it is connected like this. So, oil is going like this and then here it is it is coming over here, it is coming over here. Then what will happen? This with the low load, this is moving upwards, the kicker actuators is moving upward with high speed. All the flow are being used. Now, one thing I would like to mention here, when a crossing lines with a dot means these are connected, pipes are connected. If there is a crossing without such dot, it is not connected. Actually, in some cases for careful design, we just put it line like this, say electrical circuit, we put it like this, but do not be confused looking into this. Wherever the connection is there, dot will be there. Okay. So, what is happening? This is moving, but as you see, this is crossing, not connected. Then during rapid advancement, rapidly it is moving upward, the pressure sequence valve remained, this is the pressure sequence valve, remain closed and the main actuator is extended by two kicker actuators driven by full flow from main source. All the flow is moving this, whereas this is closed, this is not being operated, no flow is going through these sides. Now, as this is moving upward, this is a these all three are coupled to this load platform. So, we need to have some oil here also, that means this should not, the no air should be there, oil should come over there. For that, this header tank is there and from this header tank oil is coming into this cylinder, this is simply being filled. The main actuator is moved by two kicker actuators in these situations. It is filled in by oil from the header tank via pre-fill valve. And then when the work table fitted on actuators reaches to push the load, the pressure increases. Actually, any press you will find initially this say suppose it is squeezing say cotton, let us consider. So, initially you will find that cotton is put in between and there is no load, or if you think of the paper cutting machines, on the paper this actuator is moving, say it is applying the load, but initially you will find this paper cut with a gap, so no load, almost no load. Now, when they are pushed and this all this material will come it will be squeezed, in that case pressure will be failed and the sequence valve opens and pre-fill valve is closed. Now, the pressure has increased, in that case with this setting, the pressure setting is such that because this whatever oil is going this side, the kicker actuators, that is also is going to the pressure sequence valve, but this pressure is low. So, it is closed. Now, when the pressure is increased, this will open, then oil is going to this side and due to that this will be closed, and then this oil will go to all three cylinder actuator. Through this path it is going through this way and to these two cylinder it is going as it is, but the flow will be automatically divided. Flow will be automatically divided, and this is one interesting point is there, total load is distributed over there. So, total load divided by the area, that will give the pressure. Now, what we would do, suppose this load it will be distributed in such a way that in these three pressure will be same, That means, suppose this area is just a double of these two cylinders. That means, this will take one load, one unit load, this will take another unit load, and this will take 2 unit of load. It is like that, automatically this load will be distributed over the platform. Now, still there is a problem. Suppose the load is in such a way that it cannot balance. In that way, you will find that one will move faster than the other, but definitely there is some system to equalize the load. That is interesting. If you calculate numerically, when these three are moving and performing some operations with load, then the pressure will be distributed equally over that. Total flow of pump is now shared by 3 actuators, resulting in slow motion, but with higher force, keeping the power consumption by the pump more or less same. In retraction, when the main DC valve is put, now retraction has started, is DC valve, direction control valve is put in the other phase. That means, we have now connected like this. The pressure drops below the sequence valve pilot, and the return line of 2 kicker actuators are open to tank. So, now we have connected this way, say this cross, okay, and then this path is connected to this. Then this oil is going like this, and it is going other sides, okay, and oil from this side is going back to the tank. So, oil is coming from here, here. Now, this oil cannot come to this tank. What is done in that case? The sequence valve is closed again. Due to this, sequence valve is closed because we do not have sufficient pressure, and the return line of 2 kicker actuators are open to this tank. Okay. This much we have learned, but we still do not know what is happening to this main cylinder flow. The flow from main actuator is returned to the header tank via pre-fill valve, because now this is actuated, and then oil is again going back to the pre-fill header tank. So, this pilot pressure will open this one, but this path is closed. So, oil has to go back to the tank, there is no way. During non-active period, pump flow returns to the tank via this tandem valve. As this is a tandem valve, when it is in neutral position, so all the oil is going back to the tank. So, this is a very good example that when we use such pressure load and these things with a kicker actuators and pre-fill valve, we can save the energy. Only thing, as there is a tandem valve, the operation will be slightly sluggish than if we can use closed center valve, but really that does not matter, because we are using some pressure, we have to keep the material, we have to move the material. So, if there is a time delay for such operations, this really does not matter. So, this is one example of the power saving systems. Now, how this valve look like? This is the sequence circuits. As you find that the oil is coming in and oil is going out through this valve, and then this is the pilot pistons through which it can be opened also externally. Say for example, this signal is there, then this will open and this oil will go. Otherwise, if there is a certain increase in pressure, this will open and this oil will flow out. And also if you can study, this primary system pressure line is here, and then with this, when the pressure exceeds some amount, then this opened to the secondary system. Okay. So, I suggest that you should see this figure and you should study this valve. Here it is how written how it operates. The sequence valve can externally piloted. The plug P is inserted to activate external pilot. Note that for internal piloting, the plug is to be removed and the and a plug is inserted at XP port. I mean, here if you put this plug it, then not it is externally actuated, it will be actuated internally. Internal pilot is required. Also, all sequence valve are externally drained through XT ports. This is to avoid the back pressure. Say this where there is a possibility of back pressure, then draining is essential. In a carefully designed valve, internal draining is also possible by removing internal D plug with XD is plugged. So, it is also possible some internal draining through this port. And this is another view of this valve, and there is auxiliary external pilot is there. This is just to improve the performance of such valve. Now, if we look into the other circuit, the sequence regenerative circuit, in that case we have one sequence valve here, and again this is 4/3 DC valve and this is a simple pressure relief valve and fixed displacement pump. In that case, the rod end discharge flow is mixed at point M. This side flow is mixed here, and with the main flow from pump to the piston end actuator via line R, the data line, when the DC valve is put into Y positions. If we put into these positions, then the flow is going through this, and from here the flow is coming over here and this is being mixed. It is possible in regeneration, and this sequence valve, this results in relatively high speed actuation system. It is called regenerative circuit. This happens until the load moving in extension phase is enough to increase the system pressure to crack the pilot pressure of the sequence valve. Suppose it is moving at a fast speed, but the load is now increased. In that case, there will be increase in pressure. Once the increase in pressure is there, then this valve will open, this valve will be operational, and then the discharge flow from the rod end returns to the tank. Then what will happen, this flow instead of being mixed, it will be back to the tank through this valve, through this line. It will not come this way, this will directly come to this way and it will go back to the tank. So, in that way what we find, if there is less load, the regenerative circuit function will be operated and this will move at a faster speed. When there is a pressure, then this flow through this valve will go back to sequence valve, will go back to the tank, and this will operate at low speed, but high pressure. The circuit is now like an ordinary circuit utilizing the full power to move the load. While the DC valve is set at X, the pump flow is diverted to the rod end via check valve into the sequence valve. The rod end retracts, the flow from the piston end returns to the tank. This is again like an ordinary circuit. Now, the thing is that only here that if we omit this sequence valve, then this will operate at the same speed. The full flow will be mixed and it will go there. In that case, power will increase. So, without this whole circuit is a regenerative circuit. With this, we should call this is a regenerative circuit with energy saving. And with the area ratio, this is another interesting thing, the area ratio is 2:1. That means, if this area is 2, then this area is 1, but keep in mind that does not mean that rod diameter and the piston diameter is 1:2. The area is 1:2. In that case, we can have the same speed in regenerative. Now, this is another circuit. I think we can continue later also. We can study the circuit, maybe in the next lecture we will study this. So, this is with the variable displacement pump, we can have the same energy saving system. Only thing, this such variable displacement pump is very expensive. Say for example, if we the same pump, same feature, except this pressure compensation and the variable displacement part, the cost may be, if it is a cost of this pump is 5,000, with such variable displacement system, it will be at least 15,000, 3-4 times more than a pump. That is why if we go for such a system, we have to be very selective. But in the using such variable displacement pump with a proper control system, the energy savings will be more assured, and we can say more fine control will be there. We can study this circuit maybe in the next time, and this is again this is kicker circuits with an accumulator. This the same operational, but with this accumulator it further saves the energy, and in this case we do not use the open tandem center, we have used a closed center valve here. These other two circuits with unloading valves. So, in these circuits, what we differential unloading valve and pressure reducing valve. In this case, we have only simple one unloading valve. These are more or less, you can find that here we have used one accumulator, here without any accumulator, but we have used a variable displacement pump. This function and power saving more or less same. Here we can have finer control, but this is more expensive than this. And this we have followed. This book will not be available in the library. This is out of print also, same as this book, and this is also very expensive book, and I do not think our library is having. Anyway, I will this note will be available to you. Thank you for listening.